Hello everyone, welcome back to Think Lab by Saurabh. So today we are going to deep into the one of the most important advancement in modern AI, multimodal foundation model. So let's start with a simple idea. Human do not process the word in a single format. We don't just read the text, we see the image, we hear the sound, we understand the motion, and mostly important, we combine all of this seamlessly, right? So now the question is, can AI do the same? Can AI perform the, can AI can see the images, feel the sound, understand the motion, and all combined together seamlessly? Right. So traditional AI system were unimodal, right? A language model only process the text, a vision model only process the image, a speech model can only handle the audio. So all this model are unimodal. This model work in isolation, but the real world is not isolated. It is interconnected, and that's where the multimodal foundation came in. So a multimodal is a multimodal foundation is designed to process and understand the multiple type of data simultaneously. So this include text, image, video, audio. So multimodal model can perform all this text, image, video, and audio. So the core idea behind is very powerful. So instead of learning separate representations, the model learned a sheer semantic space. So what does that mean? It means that the different forms at the same concept are mapped to similar representation. For example, the word dog, an image of a dog, and the sound of a bark. So all them are encoded into nearby vector in a high dimensional space. So this is we call the joint embedding space. So, and this is the foundation of all the cross model intelligence. So now let's understand how this actually works. So there are several steps. So we will cover each step one by one. So step one, the encoder. So each modality has its own encoder. So text process using the transformer based language encoder, image are processed with the vision transformer or CNN, and audio used for the spectrogram based encoder, and video used for the temporal transformer, right? Temporal transformer used for the video, right? So each encoder convert raw input into the embedding, and this embedding capture the essential feature of input, right? Now we are moving to the step 2. In the step 2 we will perform the fusion. So now concept is the critical part is fusion. So this is typically done using the cross attention mechanism. So what is the cross attention? So cross attention allow one modality to attend to another. For example, text attending to image regions, video attending to audio signal. So this enable the model to learn the relationship across the modality. So the step 3 is the shear representations. So after the fusion model project everything into the shear embedding space. So this is where elegament happens, right? So semantically similar input, regardless of modality. So and also place together all the similar input, with the semantically place on the all together, right? And the step 4 is the output layer. So finally the model performs tasks such as the captioning, like visual questioning answer, text to image generation, or speech to text translation. So you we all these are the part of output layer. So now let's talk about the key techniques, key techniques that make this possible. So the first one is a constructive learning, right? First one is a constructive learning. So this is used to align different modalities. The model learn to bring the related pair closer and push unrelated pair apart. For example, a correct image, the correct image, caption pair that will make closer. A random image and caption pair, it's a further very large, right? So second one is a cross attention. Constructive learning we have discussed. Now we are moving to the cross attention. So this enable interaction between the modalities. So this allow the model, to dynamically focus on relevant part of another input. And third is the token alignment. So different modality have a different structure. So text has words, image has a passage, audio has a time frame. So token alignment ensure that this different structure can interact meaningfully, right? And the fourth one is a temporal modeling. So this is especially important for video and audio. So the model must understand the sequence over time. So this involves the capturing motion, transition, and causality. Yeah, right. So now we are moving to the fifth one, the instruction tuning. So modern multi-model are trained to follow the human instruction. For example, describing the image, summarizing the video, explain the diagram. So now let's move to advanced area, right? So, vision language model. First, we try to cover the vision language model. So this model combine the text and images. So example, include the system used in the captioning and visual keyword, right? So video understand the model and this go beyond the static image. So they understand the motion, event and the temporal pattern, right? Now we are moving to the cross model search. So searching using one modality to retrieve another, for example, search image using text query, right? After that, we have a world model. So this is the next frontier model that simulate and understand the real world across the space and time, right? So let's discuss the different applications. So a smart assistant, they can see, hear, and respond intelligently. Autonomous vehicle, they can combine vision, lidar, conceptual reasoning. Healthcare, they can analyze the medical imaging along with the report and signal. So content creation, like generation the video, image, audio from the text prompt, right? So these are all the application of multimodal, like educations, like personalized learning using a multiple content, right? So however, there are significant challenges also there. The first is the data imbalance. So some modality have a more data than the others, so this create a bias in learning. Second is the expensive labeling. High quality multimodal data set, like a different and also costlier to create. Third is the high compute cost. So training this model require massive resources. The fourth is the temporal complexity. So understand long video or audio stream is computationally intensive. The fifth is evaluations, right? So it's hard to measure the true multimodal understanding. So finally let's talk about why this matter, right? So we are moving from language based AI to perception based AI. So this is the fundamental shift. So AI is no longer just processing the text, it's combining to understand the world. So multimodal models are key step towards the artificial general intelligence, because intelligence is not just language, it's a perception, reasoning and interaction. So multimodal system bring all this together. So let's end with the powerful insight, right? So we are going to summarize this video. So let's end with the powerful insight. AI will understand the world, not just text, right? So that is the main things. AI will understand the words, not just text. So thank you for watching. This is the Think Lab by Soro. So learn AI, build the system, keep thinking, right? And see you in the next video. Happy learning.